Here we have a demonstration of Modbus communication between two different PLCs, master PLC right over here, and we have a slave PLC set to slave address number 1. Now on the slave PLC, we happen to have an HMI panel plugged into it, and that HMI panel is currently displaying a digital number. And what we're going to do here is demonstrate where that digital number comes from. In the master PLC, we look at the program, we see first there's a Modbus instruction that is always active. We're using a special contact that's always on to continuously, perpetually energize that box. And in that box, it's a Modbus instruction. We are using Modbus function code number 6, which is to write a single register. We're going to take the value in the master PLC that's stored in register TD1 and send that using Modbus to our slave address number 1, slave PLC, into its register DS1. Now in the master PLC, the register TD1 is the current count value of a timer, an on-delay timer. And we have two bit inputs, X1 and X2, activating this timer. So these two switches over here, toggle switches, X1 and X2, you can see the lights come on, X1 and X2. That's going to activate the on-delay timer. That current count value will now be sent using Modbus protocol over into the DS1 register of the slave PLC. In the slave PLC, we have the HMI panel connected, which happens to be programmed to show the value, the content of that DS1 register. So right now it reads 0. What should happen is when we turn on the X1 input on our master PLC, that timer should start timing. So here we go, and it should start timing. We can come over here to the HMI panel and show the result of that. 7, 8, 9, 10, 11. So this slave PLC, which has no program written in it whatsoever except for an end statement, is now getting a value sent to it over the Modbus cable from the master PLC. Now just to prove to you that this number we see on the HMI is actually coming from that other PLC, I'm going to disconnect the communications cable. So here I go. I'm going to reach over and disconnect the cable that's plugged into port number 2. When I do that, it holds and reads a value of 37. We don't get an error message on the HMI because it's still connected to that PLC through COM port 1. But the digital count value coming from the other PLC's timer can't make it to this PLC because I've disconnected the cable. Then watch what happens when I reconnect the cable. If I go over there and reconnect, I go from a value of 37 to a value of 61, 62, 63, 64, because meanwhile the master PLC never stopped timing. So I'll turn this off. And then when I activate the X2 input, that should reset the timer in the master, and this value right here should go to 0. Here we go. And there it goes. So that's a demonstration of using Modbus to communicate between two PLCs, a master and a slave, sending digital information in the form of an integer number using Modbus function code number 6, which is to write a single register.